Okay, I'm going to go ahead and get started. Welcome to the Fulton Schools of Engineering Tutoring Center's CSE 110 workshop. Today's agenda, we're going to go over the presenters, the objectives, and we're going to go over loops, methods, and classes. Here are the QR codes for our engineering tutoring center's social media. If it would be great if you follow them, you would get regular updates about our workshops and our schedules, the tutor schedules, and the subjects being tutored in the centers. Here's a link to sign into the workshop. I've put it in the chat as well. I'm going to remind you guys at the end of the session as well to sign in. I'm Aishwariya Ranjan. I'm a computer systems engineering junior, and I joined the special programs team this fall. Okay, so today we're gonna learn loops. Excuse me for this. We're gonna learn loops, methods, and classes. So first off, loops. Okay, so we're here. In Java, there are like three types of loops. We have the while loop, the for loop, and the do while loop. So we're just going to go over how each of them run. So in a while loop, given that we have an integer x with a value of 5 assigned to it, why we check the condition. So while x is greater than 0, if this condition is satisfied, we jump into the loop and run the loop. And after we're done running everything inside, we come back to check the condition. And we keep running the loop until this condition is satisfied. So while x is greater than 0, x is 5, so it is. We go into the loop, and inside the loop, x is decreasing by 1. So x is 4 now. We check the condition again. X is still greater than 0. We go back and we check it, and this keeps happening until we have x is 1, and then we go inside and x is decreased by 1, so it becomes 0. And then when we check the condition, it's not going to be satisfied, so we exit the loop. So the loop is exited when x is 0. Okay. And then for the for loop, we again have int x is equal to 5. Oops. We again have int x is equal to 5. And now inside the for loop, we have 3 conditions. The first is the initialization, what we're beginning with. Then the second is what's the stopping condition. And the third is what we're updating I with after each iteration. So we begin with I is equal to 5, and we're going to run this loop until I is 0. I is greater than 0. And for each iteration, we're going to decrease the value of I by 1. So we, so we go into the loop, and what we're doing inside the loop is the same function, x is equal to x minus 1. We're decreasing x by 1. And then for this case, we're not checking the value, how x is being updated. We have our own variable over here that we're checking. So for the first iteration, I is 5, it's greater than 0. So we jump into the loop and we do whatever we need to do, and then we come back, and then I will be decreased. So now I is 4, it's still greater than 0. So again, we jump into this, and after we're done, we come back. So this keeps happening until we keep decreasing the value of I, and until I becomes 1. So once it's 1, it goes back in, does whatever it needs to do, it comes back. Now I has decreased by 1 again, I is 0. And now this stopping condition is, this condition is not satisfied. So we exit the loop. So x is 0 when the loop is exited again. Now in the do while loop, how it's different from the while loop is that you run the loop at least once before checking the condition. So x is 5, then we jump straight into the loop. We have to increase this time x's value, and then we check the while condition. So 5, x is increased by 1, so it becomes 6. And then we check x is less than equal to 10, it's satisfied. So then we go back and do whatever's inside the loop. And we keep going until suppose we have x is 10. And now x, when it goes inside the loop, it becomes 11. We increase the value. And then when we check the condition, it's no longer satisfying the condition. So we exit the loop when x is 11. Okay, here's an example problem with the while loop. So we start with int x equals 10. Our while condition is x greater than equal to 0. So we run this until we'll stop this loop only if x doesn't satisfy this, that is x is less than 0. And until that point, we keep going inside the loop and printing out x, and then we update the value of x by decreasing it by 2. So the question is, what is the last value that will be printed out? I'll just stop here for a minute and then show you the answers. Okay, so x is initialized to be 10, and then we go on to the while loop. So yeah, so the steps are, we check the while condition. This condition is satisfied, so we jump into the loop, and then we print out x and update the value, so we decrease it by 2. And again, we go back, so 10 minus 2 is 8. The condition is still satisfied, so we go back into it. So this would repeat until x becomes 0. So x is 0. It would still satisfy the condition, and it would print x out. And then x 0 minus 2 would be negative 2. So at that time, this condition will not be satisfied. So we jump out of the loop. So the last value to be printed out would be 0. Okay, here's a breakdown of the for loop. So the first condition we have in the for loop is the initialization, the first term. And first we initialize, for example, int I. Then we create a condition like a stopping condition. Suppose int I less than equal to 10. And after that condition, if the condition is true, then we execute the body of the loop. And then we go back and we update the value of int I over here. And then we check the condition again. And if it's true, again, we'll run the body of the loop. But if it is false, we go outside the loop, we exit the loop. For the do while loop, first we go into the body of the loop, and then we will update the value, usually whatever is mentioned in the while condition. So if while is checking for x less than equal to 15, then x should be updated here in some way. So we update that value and then we check the condition. If the condition is true, then we run it again. But if the condition is false, then we exit. Moving on to nested loops. So the body of a loop can contain another loop, and for each iteration, so if there are two loops, as shown in the example over here, the one that comes first is the outer loop, and it will be enclosing another loop. So that would be the inner loop. So for each iteration of the outer loop, the inner loop iterates a number of times completely. What that means is if we see the stopping conditions for these two loops, the outer loop will run until I is less than equal to 5. And it starts from 1. So until i's value becomes 5, it will run. And the inner loop, it starts from 1 as well, and it will run until j reaches 2. So first we go into this loop. I is 1. Okay, so we jump in, we go into this loop now. And now j is initialized as 1. We run whatever code is inside j. And then we go back over here. And then j gets incremented. And then now j is 2. So we run this code again. And then we go back to this for loop. J is now again it gets incremented. J is now 3. So it doesn't satisfy this condition. So we're going to exit this loop. And when we exit this loop, that means we finished executing the body of the outer loop. So now we're going to go back and update the value of the outer loop, update I, and the condition is still satisfied. So we run this once again. So when I is 1, j runs twice. Then we go back, I gets updated. So I is 2. Now j runs twice again. And then I is 3. It runs, j runs twice again, and it happens until I is 5. So for each run of the outer loop, the inner loop is running twice. Okay. So here is a code of a nested loop. We have two variables declared. Int weeks is equal to 3, int days equals to 7. We have an outer loop over here, which for which it's initialized by int I equals 1. I will run until I is less than equal to weeks, that is I is less than equal to 3, and then it gets incremented by 1. And inside this for loop, we are printing out weeks plus I, the number I. And then further in the outer loop's body, there's another loop. So that's the inner loop. And that for that j, the initializing condition is j is equal to 1. Stopping condition is j is less than equal to days, that is 7. And j is also getting incremented once for each run, incremented by 1. And it's printing out days and the number j. So I'm going to give you guys a minute or two, and I want you to write the output, what the output would look like, and I'm going to show it to you. Okay. So this is how the output would look like. So first, when we go into the inner loop, we print out weeks and I. So the first thing that would print out is weeks and I is equal to 1. So week 1. And then we would go into the second loop, inner loop, and that prints out day and the corresponding j. So day 1. And then we're running back into j. We're checking j again, the condition. We are incrementing it. So j is 2 now. It satisfies this. J is still less than 7. So it'll print out j2 and day 2. And this is going to keep printing until day 7, until this condition. So once we're done printing it up till 7, it's going to exit this for loop. And then it's going to go back to this loop. It's going to increment the value. So now I will be 2 and 2 is still less than 3. Weeks is 3. So then we go back into this loop and we're going to print week and I is 2. So week 2. And the inner loop runs the same way. So we're going to print from day 1 to day 7. And then similarly, week 3, day 1 to day 7. Okay. Now we'll move on to methods. So the syntax of method is like this. We start with a modifier, the return type, the name of the method, and a list of formal parameters. For example, if we have public static int current age, and the inputs over here are the int year of birth and int current year, we have this method that will calculate your age by subtracting your year of birth from the current year and returning that value. So over here, public is the modifier, public static is the modifier, return type is int. So you're returning a number, right? Current year minus year of birth would give you a number, and that's what you're returning. So that it's an integer. So that's why the return type of this method is int. And then we have the name of the method, current age. Remember to name your method something that describe what they're doing, so it's easy to call them. And we inside the list, formal parameter list, we have two integers, integer variables. These are basically what input you would give to call while calling this method. So we're going to see an example of this. So we have the same method as the previous page. And we have another method over here, which is public static void display age. And it is taking in the input of int age, integer. So, and when inside the method, we're printing out this statement, your current ages, and we're taking this variable to fill in the number. So why this is void is because you're not returning anything. In this method, you're just displaying your age, but you're not returning any value. So the return type is void for this particular method. So to see how this program would be called in the main, we have this. Okay. So this is your main. You might have some other code in the starting. But when you call this, so I have a variable int my age equals to whatever this is going to return back to me. This method is going to return back to me. So we know current ages return type is int. So that matches my variable type over here. So I'm returning an int to this int. So that is valid. So I'm going to get a number out of this, which I'll return to my age. And this is how I'll put in my inputs. So for me, my year of birth was 2001 and the current year is 2021. So this is how I would call this method. And then, so it will go into this method, it'll do subtraction and that it'll return 20. So then that 20 would be stored in this int my age. And now you want to display that. So you're gonna call this method display age, and how you call that is display age, and you just put this variable inside over here in the formal parameter list. This is now an actual parameter. So formal parameter is what you write down over here when you're defining the method. But once you're actually putting in a variable in it and calling it, this is an actual parameter. So this would call the display age method. And over here, it would print out your current age is, and it would take the age from here, which is 20 that I received from like the current age method. So it would print out your current age is 20. So the methods are divided into these 4 categories. We have void methods with empty formal parameter lists. So void method, they don't return anything, and they don't have any inputs. To call them, you don't really need an input. It's like your toString method. It's void, it's not returning anything. It'll just display what you have in the program. So it doesn't need inputs as well. So no parameter list, empty parameter list. And then we have void methods with a formal parameter list, like the display age we saw on the previous page. It's not returning anything, so it's the return type is void, but it has a parameter list. It needs int age to do whatever it needs to do inside. And then we have non-void methods with no parameter lists. So it'll be like public static int something, and it needs no parameters. It needs no input to do whatever it was doing, but it will return something back to you. And you have non-void methods with a formal parameter list, like current age. It was non-void. It was returning an int, and it was taking in 2 input integers to run its functions itself. Okay. Oops. Okay, yeah. So we're gonna move on to classes now. A class is defined to be a template that describes the behavior state of the object it supports. So we're gonna see examples which will make this much more clear, just to have these definitions down. And an object is, objects have states or behaviors. So object is an instance of a class. So you would define a class, and then you would make an object of the class, which would have the behaviors described in the class. For example, an employee class could have state and behaviors like name, employee ID, or phone number. And then you could call an object like employee. For example, my name, employee Aishwariya equals new employee. So Aishwariya is an object of the employee class. I will have all the states and behaviors like name, employee ID, and phone number. So over here, I have defined this class. So this is how we define a public class employee. And inside I have, remember when you make a class and you put 2 brackets over here, you don't need a semicolon at the end. Inside I have a few variables. I have int ID, string name, and int phone number. Now, how would I use this in my main? I want to create a new object of this class. So I have employee1 equals new employee. So this is, I'm creating an object of the employee class. So this employee1 will have all these things assigned to it. Now I'm making a scanner object. So in this, so scanner is predefined class in Java. So it has, this is basically the same as what I'm doing over here, right? Employee1 equals new employee, scanner scan equals to new scanner. And yeah, so we're creating a scanner object here. So it's the same thing. Now I'm asking user to enter the employee ID, and then I am saving that into employee1.id. I didn't have to declare any IDs for employee1 separately. It already has whatever is inside the employee class. So to access those, I use the dot notation. So employee1.id equals to scan.nextInt. So whatever the user is entering, some number would be stored in employee1.id. So for that employee, all these three values, if I define them, they would be stored for that particular employee. Next, I'm entering the employee's name, and I'm similarly storing that in employee1.name, and whatever the user is entering will be saved in that. So that name and ID is stored specifically for employee1. So if I want to print it out, I could just do employee1.name plus has ID employee1.id. So that input would be like this. So when I run the program, it will prompt me to enter an employee ID, which I did over here. Then it prompted me to enter employee name, which I did. And then it returned this. It remembered that employee1 has this name, employee1 has this ID. So John has ID, whatever. Okay. So classes use methods. So classes can have methods inside them. And there are two kinds. So it could have a static void method. And like this code says, the static method can be called without creating objects. So for the employee class to call it, you had to create an object. But these static methods can be created without, can be called without creating an object of it. But the public methods, they have to, you have to create an object in order to call them. So this is your main function starting from here, the main method. And like over here, my static method. So this is a static method. It can be called just like this. No need to write my static method something equals to new my static method. This is how you call it. But if you did that to the public method, my public method, you would get a compilation error. So to create an object of this, you would have to do, so to call this, you would have to create an object of this class. So main, my object equals to new main. We created an object of this class, which is called main. And then we could call this particular method by referring to it through that object. So my object dot notation, again, because this method is within this class, so it can be accessed by any of the class's objects. So my object dot my public method, this is how you would call this method. So classes can be expressed by UML diagrams, Unified Modeling Language. That's what UML stands for. It's a concise, easy way to define and express them. So a UML diagram has three parts. The first part is the class's name. So we have a class called account over here. Here are the variables which will be declared inside the diagram, inside the class, I mean. So as you can see, ID colon int equals 0. So this is, so you have a variable ID of the type integer. So, and it's initialized to 0. So when you write your class, you would write int ID. So you would first have public class account and those brackets, and then int ID equals 0. Similarly, you would have double balance equals 0.0. So this is how you would declare your variables according to this UML diagram. Now we also see that this also has class as methods. So over here you have the name of the method, and this is inside the brackets is what kind of formal parameter list, what kind of inputs that method takes, like when you're calling it. And after the colon, you have a double or a void written. So that is basically a return type. So set ID will return nothing. So it's void. Get balance, however, you're asking for balance. Basically, you'll in the code, you'll be supplying the balance back to the user. So you're returning a value, and that is a double type value. Okay. So now you might have seen over here, you had minus and plus signs. So these are called visibility modifiers. The plus sign, it means that particular um, method or variable is public, and it can be accessed by any other class from anywhere else. The minus sign means it's a private variable or method. It can only be accessed within the same class. So within the class, if I have a particular method, that method could call that variable, suppose, but if I'm in some other class, I cannot call that variable because it's private only to that particular class. Protected, it can be accessed, it's denoted by the pound or the hash sign, and it can be accessed by other classes in the same packages or the child class of that particular class. So if I have employee and then a class employee, and then the child class of that is a student employee or like faculty. So we would inherit some, you're going to learn about this later. You would inherit means basically have some same functions, which would be copied down from the employee class down to these two student employee and the faculty classes. And if you use the hashtag to for any of the protect methods or variables, you could access the variables in employee from these two classes on the bottom as well. And if it has nothing, that by default, that means that it can be accessed by classes in the same package. So now here's a little practice question for you. I want you to write a program with a method named getTotal that accepts two integers as arguments. So that's your input. You would put that in the formal parameter list and return its sum. So, and you also have to call this method from main and print the results. So how would you do that? I'm going to give you a few minutes on this and then we'll discuss. Okay, so here's how we do this. First of all, since the method asks us to print something, we're just going to import the scanner class. And then um, this is the class's name. The entire program has to be enclosed in a class. So we just need that sum to number, doesn't matter. Public static void main, here's your main function, and public static int get total. So first we could write down this method. So over here, the question asks us to name it get total. It accepts 2 integers as an argument and returns a sum. So public static, because we want to call it from here, int, because it's returning a sum, so that's an integer value, because the arguments are 2 integers, so the sum would be an integer. So public static int, the name is get total, and we're accepts 2 integers as arguments, so int number 1, int number 2, and we just have to add them up. That's what the function is told to do. So return, we are returning number 1 plus number 2. So that would be an int. That's why this is int over here. Now let's see how to call it in the main function. So first of all, we are making a scanner object over here, scanner class object, and we're declaring 2 numbers, int num1 and int num2, because we need to get user input for these 2 nums and store the value in them. So we ask user to enter first number, save whatever they enter into num1. Similarly, we save whatever they enter into num2. And then int sum would be, we would have to call this function. So get total, and it would, the arguments would be num1 and num2. That's what we want to add. So we'll write down this. So int sum equals to get total num1, num2. This would call this function. So now from here, we jump to this function, and then we execute whatever's inside here, which is the addition of these 2. And then we have to return this back. So once you return, it will go back over here at this space. So we have, like, suppose you had to do 5 plus 6. So now you have 11 over here. It's an integer that will be stored into this sum. So when you print this out, you're calling this, so you're printing this sum out over here. It will be sum 11. So that is how this code runs. So here's the workshop summary. We went over loops, how for loop, do while, and the while loops run. Then we went over nested loops, a loop within a loop. There's an outer loop and an inner loop. For each run of the outer loop, the inner loop runs like until its stopping condition. So if the outer loop has to run 5 times and the inner loop has a stopping condition of 7, we run once, run this inner loop 7 times, then go up back to for run number 2 for the outer loop. The inner loop again runs 7 times, then it keeps going in that way. And then we went over methods, how to declare methods, the syntax, how we call methods, and the categories of methods. And finally, we went over classes, how to create classes, the class objects, how to call them, create the 2 different types of methods also within classes. And we went over how classes are expressed in UML diagrams. That's all I have for you today. Thank you for attending.